Today we'll discuss dynamic friction. Now what exactly is dynamic friction? To understand that, we'll revisit a thought experiment that we had done on the video on static friction. What we had was a rigid floor on which there was a block of mass m and there was a person pushing it. And this person was applying a force on this block and this force was of magnitude E. So this is the block and there's of course gravity acting on this system, so there's a downward force of mg, an upward normal reaction, an effort that the person is applying, and the opposing friction force. And we had seen that this system has to be balanced. The thought experiment that we had conducted was that suppose this person continuously increases the amount of effort that he's applying. So we have time on one axis, force on the other, and with the blue pen we draw the line, we plot how much effort the person is applying. So the effort in this case is increasing linearly, and what we had seen, what we experimentally observed, that the friction generated, which is depicted by the green line, follows this blue line till a certain point, and once it has reached a certain threshold, these two lines diverge. So they can either diverge like this, or like this. And what we had finally said was that this threshold is called your critical friction, F critical, and this is equal to mu static into normal reaction. And this region, which is present before the friction force reaches critical value, is static. That is, the body is not moving during this time. Now dynamic friction actually deals with this region. That is what happens to the friction force, how much friction forces continues to be applied on the body once this body has started moving. So the analogy that we have taken, that we have to push a bed. So we have to reach a certain force before the bed starts to move. But even once it has started moving, it still offers resistance. We still have to apply force. So if we have to keep the bed moving at a constant speed, how much force do we have to apply in order to counteract the friction? To understand that, we have to understand how much friction is being applied. Like what I had said previously about the critical friction, that it is only a model. It is something that we have conjectured and then verified experimentally that the critical friction is indeed some constant into the normal reaction. What model we'll be fitting over here is again a conjecture, but is largely true, so it's useful from an engineering point of view. So as you could see from this equation, this friction force, that is the dynamic friction which is being applied on the body once the body has started moving, is constant. It doesn't matter what speed it is going at, the dynamic friction is constant, and it is given by mu dynamic into the normal reaction. So it is very similar to the critical friction. The friction dynamic friction is coefficient of dynamic friction into the normal reaction. So if we actually have to plot this over here, then it's a straight line which is either here or here or here, depending on what your coefficient of dynamic friction is. If your coefficient of dynamic friction is greater than the coefficient of static friction, then it will be this line, which is higher than the critical friction line, which is this line. If it is equal, then these two lines will be coincident, and if it is lesser, it will be this line. Usually what is observed is that the coefficient of dynamic friction is equal to a constant, and secondly that the coefficient of dynamic friction is less than the coefficient of static friction. These are real world observations. Basically, why is the coefficient of dynamic friction less than the coefficient of static friction? When we are trying to start a body from stop, the irregularities that cause friction are well locked into each other. So to get them out of this locked up position is difficult. But once these bodies are moving, then these irregularities are no longer locked. They are in fact separate from each other. So once we have started moving them, since these irregularities are no longer locked, the coefficient of dynamic friction is less. So let's just mark this over here. This is dynamic and this is static. And since the gap over here is much less than the gap over here, the coefficient of dynamic friction is less than the coefficient of static friction. So we'll use dynamic friction more in topics which are related to motion.